সেক্ষেত্রে যদি স্যার আমি ওই ক্রিটিক্যাল রেজিস্ট্যান্সটাকে কমিয়ে দিই তাহলে কি স্টেবল ভোল্টেজ পয়েন্ট একটা পাওয়া যাবে না?
পাওয়া যাবে, you can get that, but how you will reduce the critical resistance, that is the issue. You can increase, but how will reduce that? You can use some shunt to reduce that, but again that will reduce the flux, so that is the problem, isn't it? So when did you have the class? Last class? I have to open that whiteboard.
Last class
24th?
last class to last
24th, sir.
Okay.
Yes, sir.
The whiteboard is visible?
Yes, sir.
It's a
So I think this is the last class that we discussed. So many things are there in the same whiteboard. All we have discussed. So this is the characteristics. No load characteristics we are discussing. Now OCC. Now this is the point. Okay, so practically what happens? Suppose you are starting the machine, okay, and you are expecting some voltage will build up. Okay, so suppose the machine is a shunt machine. And you have connected a voltmeter here, and you are also connected. You have also connected some ammeter here. Okay, now you have started rotating. Okay, now what will happen if the resistance is the resistance, field resistance is more than the critical field resistance? Now whenever you will see the voltmeter, so initially if these are the things, suppose it's a 150 volt voltmeter in steps of 10, suppose 10, 20, 30 like this. This is a voltmeter. Okay, so initially what we see, due to the residual flux, the indication it gives when it rotates around 6 volt. Okay, so 4 to 6 volts we get. So that is due to the residual voltage. Due to failure of some of these conditions, that means if the field resistance is more than critical field resistance, or the speed is less than critical speed, all these condition, the voltage will be stuck at this voltage, this 4 to 6 volts only. It will not build up. But if all the conditions are okay, then what will happen? This indicator will slowly, first it will increase slowly, because initially the steps are very small. Gradually the steps are increasing, so it is slowly it will increase. Then here it will increase a fast rate, then again it will increase a slow rate, then it will settle down at some, suppose 120 volts like that. So that is the process of voltage buildup. So that you will see in the voltmeter, because it's a transient phenomenon. For shunt machine, it's a transient phenomenon. For shunt machine, all the points are unstable except the stable voltage point. Except this stable voltage point, all the points are unstable, unlike the separately excited generator. So that is the difference between the OCC of separately excited generator and shunt excited generator. Okay, I think you haven't got this point, isn't it?
No,
You
sir.
got this point. Okay, now you see the
No,
same machine we can
পার্টটা যেটা
run.
বললেন ওটা একটু
হ্যাঁ বলো. Okay, so I'm just explaining.
ট্রানজিয়েন্ট পার্টটা স্যার
I'm just explaining that. Suppose the same machine you are running as a separately excited and shunt excited, the same machine. That is the advantage of a separately excited machine. It can also be run as a shunt machine. Okay, so this mode is called the separately excited, and the previous mode is called the shunt excited. Now here you have ammeter and you have a variable resistance. Now by this variable resistance, you can vary this field current, isn't it? Okay, so that means this field current is an independent variable here. Here the field current is independent. Okay, and what is EA? EA is some sort of function of IF, isn't it? And if this you can define, this is also defined. For each IF, you will get some EA, isn't it? For each IF, you will get EA.
yes sir.
Okay, suppose IA is 0, you will get 4 volt because residual flux is there. Suppose if IA is 0.2, suppose you will get 10 volts. Suppose this is 0.4, you will get 25 volts. So like this, if you increase the field current, the voltage will increase. Now in case of shunt, you won't get these points because here the field current is not independent. Field current itself depend on the EA. Are you getting? So field current depends on EA. Again, EA depends on field current. So therefore, here you won't get all this point except this one. So here all these points are unstable except this point. Now in separately excited machine, all these points are defined and stable because you can get all these points individually. Okay, that means you will get the same curve as in case of separately excited generator, but the curve you cannot trace the curve except this point. You won't get any point. Now is the point clear? বুঝতে পেরেছো কি হচ্ছে এখানে? তাহলে এইখানে প্রত্যেকটা পয়েন্ট যেন ট্রানজিয়েন্টের মধ্যে থাকছে। except this point. এই পয়েন্টটা যখন আসবে তখনই এখানে একটা তুমি স্টেবল ভোল্টেজ পয়েন্ট পাবে। Because in by this voltmeter, this type of normal analog voltmeter or maybe digital voltmeter, you can measure only the stable voltage. If there is some fluctuation, if there is some transient, you cannot track that. You cannot measure that. If you want to measure any transient kind of thing, then you have to go for a different kind of measuring instruments, maybe some storage instrument. Okay, some storage oscilloscope also. You have to go for that. Okay, so this type of normal voltmeter, ammeter can measure only the stable point, only the stable voltage. So therefore, if we go for these laboratory experiments, we'll get only this point, only the stable voltage point in case of shunt. So that is the only difference between the shunt and separately excited DC generator. Otherwise, their characteristics is ideally same. There is no difference. Can you tell me why?
Same
Their OCCs are exactly same. OCC which we get for separately excited and OCC
Sir,
which we get for shunt.
Characteristics are the same.
Exactly same. Their characteristics are exactly same. If we could, if it is possible to track the characteristics for shunt, we'll get exactly same characteristics as we get for separately excited one.
Yes, sir.
Why?
একবার একবার বলুন।
আমি বলতে চাইছি যে এটা যদি পসিবল হতো যে শান্টের ক্ষেত্রেও আমরা ওসিসিটাকে ট্র্যাক করতে পারতাম, ওসিসিটাকে ড্র করতে পারতাম, তাহলে যে ওসিসিটা আমরা পেতাম, কার্ভটা পেতাম, সেপারেটলি এক্সাইটেড এর ক্ষেত্রে একই ওসিসি পাবো। ওসিসিস উইল বি
কারণ স্যার দুটোই বিএইচ কার্ভ ফলো করবে।
হ্যাঁ, বিএইচ কার্ভ তো ফলো করবে, হ্যাঁ, কিন্তু মানে কাছাকাছি। আর your answer is very close but not to the point. Okay, so basically you see that your OCC is a scaled version of BH curve, isn't it? So that means the BH curve is basically the property of the magnetic material. If the magnetic material remains same, because the same machine you are operating as a separately excited motor generator and shunt excited generator, that means your magnetic system remains the same magnetic material is there. Is that clear? So that means magnetic material doesn't change, means BH curve will not change. If BH curve doesn't change, then OCC will not change. What about the excitation? Is that clear? Got my point?
Yes sir.
Yes, sir. Yes, sir.
Okay, so magnetic material remains same, means here BH curve remains same and the OCC will remain same. So that is the point. Now, in case of series excited generator, we can't draw the OCC at all. কিন্তু আবার একই পয়েন্ট, যদি আমরা ওসিসিটাকে ড্র করতে পারতাম তাহলে কিন্তু একই ওসিসি পেতাম। But in case of this series excited generator, we can't draw any OCC because series excited generator doesn't generate any voltage. Why? Because the field will not be excited at all. Suppose this is a series excited generator. Okay, and you have connected a voltmeter there. So that means it's open circuit, isn't it? Okay, suppose initially a 4 volt is developed here. Due to the residual flux, you are rotating this. Due to the residual flux, 4 volt is generated across the armature. Now this 4 volt couldn't flow any current through this field because field is open circuited. Because field and armature are in series, but this is OC, open circuit. Isn't it? So that means field current will not increase, flux will not increase. That means the voltage will remain at this residual voltage only. Is that clear? So that means OCC characteristics you cannot draw for series connected DC generator, because in series connected generator you will not get any voltage build up. Is it clear? Now I missed one point. Bolo? Any doubt?
Yes, sir. Clear. No, sir.
Okay.
স্যার এই যে ভোল্টমিটার গুলো ইউজ করা হচ্ছে, এর মোটামুটি রেজিস্ট্যান্সের রেঞ্জ কতটা হলে আমি ধরে নিতে পারি যে ওপেন সার্কিটেড হয়ে গেছে, মানে ওটার কনসিডারই করব না, এরকম কি রকম রেঞ্জে হলে এই জিনিসটা হবে?
Okay. Actually, the armature resistance is in the order of 1 ohm. Okay. So if this is at least 10 to the power 3 ohm or more than that, 1 kilo ohm or more than that, generally it is in the range of that only. 1 kilo ohm or 10 kilo ohm or like that. So you can take this perfectly open circuited, because if your 10 kilo ohm is there, so how much current will flow? Only some leakage current may flow.
Okay, sir.
Some current should flow through the voltmeter, otherwise voltmeter couldn't measure any voltage, isn't it? ভোল্টমিটারের মধ্যে দিয়ে কিছু কারেন্ট না ফ্লো করলে ভোল্টমিটার কি করে সেন্স করবে যে কত ভোল্টেজ হলো?
হ্যাঁ স্যার।
So ideally it should be it is infinity, but practically it is not infinity. Anyway, আর আমরা কি বলছিলাম? Okay, so one point I didn't mention in the last class, that another point number 4 is there, for which the voltage build-up process may fail in case of DC shunt generator. Okay, so that is very simple. If the connection is not proper, okay, if the field, what is happening? If the connection of field is not proper, that means what? Suppose this is the connection, this is the connection for which the voltage is getting built up. Now if the connection is like this, if the connection is F2 F1, so that means if F2 is connected with A1 and F1 is connected with A2, then what will happen? Initially what you are getting, suppose initially you have a residual flux, thereby you are getting some voltage. Now this voltage is producing some field current. Now this field current is producing extra amount of flux, which is added with the phi 0 and give rise to the net amount of flux in the magnetic system. Okay, now this plus, you can assume this is positive with respect to some connection of this field circuit. Okay, suppose for this A1 F1 connection, if this sign is positive, for A1 F2 connection, this sign can be negative, because in that case the flux will be opposing to the residual flux. Okay, so generated flux, additional flux generated due to this field current can negate the residual flux. In that case, instead of increasing the flux, you will get decrease in flux, isn't it? And the flux becomes 0, and you will not get any voltage build up. Is that clear? Won't get any voltage build up if the field connection is not proper. So that means instead of cumulative addition of flux value and corresponding to the voltage value, you will get reduction in flux value from this residual flux. So field connection should proper. If during the starting of this machine, if the voltage is not getting built up, then you have to reverse the field connection, because for you it is not possible to know that at what connection the voltage will build up. Suppose all the conditions are okay, but still the voltage is not getting built up, then you have to interchange the field terminals, and you have to check again whether the voltage is getting built up or not. If still the voltage is not getting built up, then you have to check the ammeter. Okay, if this ammeter is not proper, that means if the ammeter is open circuited, if the coil is coil has broken, then also the same thing may happen, because if ammeter is the essential part of a circuit, if ammeter is out of order, that means there is no current through it, and through the field no current will flow and the voltage will not build up. So that is another possibility. That is a practical one. That is not written in the book, but that is a practical one. If ammeter is out of order, then also you will get the same thing, your voltage will not build up. Is that clear? So that is the thing. So anything you want to ask?
স্যার লাস্ট পয়েন্টটা একবার বলবেন?
লাস্ট পয়েন্ট অ্যামিটার নিয়ে যেটা বললাম,
অ্যামিটারে, হ্যাঁ ওইটা।
হ্যাঁ আমি বলছি যে suppose you have fulfilled all the above 4 conditions, but still the voltage is not getting built up in a DC shunt generator, then what may be the error? Okay, এটা এরকম হতে পারে যে অ্যামিটারটা খারাপ হয়ে গেছে, the অ্যামিটারের কয়েলটা কেটে গেছে। ওকে, সেই জন্য এখান থেকে কারেন্টটা আসছে না, তাহলে ভোল্টেজ বিল্ড আপ হচ্ছে না। ওকে, so what you can do, you can bypass this ammeter and you can check whether you are getting the voltage build up or not. Field polarity can be okay, so field polarity change করলে এই সমস্যাটা যেতে পারে আর কি, যেটা আগে বললাম। ওকে, আচ্ছা, তাহলে the OCC is over. Then we can go for another characteristics, which is called the external characteristics.
স্যার লোড ক্যারেক্টারিস্টিক্সটা তো হয়নি।
লোড ক্যারেক্টারিস্টিক্সটা তোমাদের নেই, তোমাদের এই দুটোই আছে সিলেবাস। এই
আচ্ছা
দুটো ইম্পর্টেন্ট বেশি, কেননা এক্সপেরিমেন্টও আমরা ল্যাবরেটরি এক্সপেরিমেন্টও এই দুটোই পড়াই।
স্যার
বল।
স্যার এখানে এটা তো আপনি ইজির সাথে আইজির গ্রাফটা করলেন, আরেকটা স্যার লোডের অ্যাক্রস যে ভোল্টেজ, ওর সাথে যদি আইএল এর গ্রাফ করতে একটা প্যারাবোলিক গ্রাফ হয়, তাই না?
বলো কি বলছো?
আমি বলছি আরেকটা যে আছে না, ওটা হচ্ছে লোড ভোল্টেজের সাথে আইএল বা আর্মেচার কারেন্ট, লোড কারেন্ট বা আর্মেচার কারেন্টের গ্রাফটা একটা প্যারাবোলিক গ্রাফ হয় না?
প্যারাবোলিক গ্রাফ কিসের সেটা?
হ্যাঁ,
that is the external characteristic
ওই
that I will
লোড
discuss.
ভোল্টেজ।
Are you talking about the external characteristics? The external characteristics is
load voltage and
parabolic
load
in
current.
case of external characteristics is parabolic in case of series only. Series motor, series generator. Series generator ক্ষেত্রে ওইটা হয় external
স্যার
characteristics.
শান্টের জন্য তো হয়
স্যার
স্যার,
শান্টের জন্য না?
শান্টের জন্য হয়, কিন্তু
শান্টের
শান্টের
জন্য
জন্য
তো হয়।
গ্রুপিং ক্যারেক্টারিস্টিক্স হয়। শান্টের জন্য ক্যারেক্টারিস্টিক্স গ্রুপিং হয়। গ্রুপিং means from a finite value it decreases. শুধু শান্টের জন্য না, সবার জন্যই হয়। শান্ট কেন, সেপারেটলি এক্সাইটেড গ্রুপিংটা কম হয় কিন্তু হয়। So that is the external characteristics that I am going to discuss today. So that I have not discussed. I have discussed only the open circuit characteristics or no load characteristics. Okay, so now I will discuss the external characteristics. So the external, the no load characteristics OCC is basically a plot of EA versus field current that you have seen, because EA is basically VT when load current is 0. So সেই জন্য আমরা VT না লিখে EA লিখছি। Basically we can measure the VT only. because we can measure the voltage from the terminal only. Okay, now for external characteristics, what we plot the terminal voltage. Here also the same, at the same point you have to measure the voltage. That means at the terminal only. But here we should call it VT because we will not run the machine only at the no load condition, not only at IL equals to 0. Rather we'll run the machine for different load. Okay, so therefore, so it's a curve VT versus the load current. So that is the external characteristics. Okay, now if we take a shunt machine, in case of shunt machine, okay, can I call it a shunt machine? Hmm? Can I call it a shunt machine?
sir.
Why? Here
Yes,
the
no load.
Yes, sir.
but here the field is connected in series with the armature, isn't it?
Sir, we should apply a
Sir,
voltmeter
এটা
parallel
open
to
circuit.
the
Open circuit.
Okay,
voltmeter apply.
so that means we can call it shunt only with respect to the load. If we don't connect the load,
Yes,
I
sir.
don't know where I will connect the load. If I connect the load here, then it will be a series motor. Okay, so it can be called a shunt generator with respect to the load. When 3 elements are connected, then the term shunt comes. Is that clear? So then we can call it shunt because it is acting as a shunt. There are two paths with respect to the armature. There are two paths. So current can flow here, current can flow here. So therefore, it is called the shunt configuration. So this is called the load current, this is called the field current, and this is the armature current. So that means here the armature current is getting divided into load current and field current. Okay, but this field current is very small compared to the load current. Sometimes what we write, the armature current is almost equals to the load current. So armature current and load current is almost same. Because suppose the load current, for an example, if the load current is 100 amps, the field current may be only a few amps, that means 1 amp. So just like this. So therefore, that is the thing. Okay, now if the load current is 0, then what will be the point in this curve? How can we get that point if the load current is 0?
Sir,
Have you
we
thought
have
of-
to obtain the rated EMF, no load EMF.
Okay, so that is the point corresponding to the stable voltage point at OCC curve. So this is the EA. So that is the stable voltage point in OCC curve, from where the external characteristics starts. So the starting point of the external characteristics is basically the stable voltage point of the OCC curve. Okay, now depending on the type of excitation, the characteristics varies. In case of shunt, we get Generally we get drooping characteristics like this. Because why? Because we know this expression Vt equals to EA minus
EA minus IARA.
IARA. Vt equals to EA minus IARA. Okay, and if IA here, as I told you, you can also approximate this IA to IL. Sorry, just a minute, it's not getting changed. Anyway, so EA minus IL RA you can write, because you are taking here IL only, not IA. So if IL is increased, the Vt will drop for a constant E assumption. Remember this assumption. If we assume EA to be constant, then if we increase the load current, the terminal voltage will drop. Okay, so this is a simple voltage equation. This you can also expect for any battery, which is another DC voltage source, storage batteries. If the load is increased due to the internal resistance of the battery, the voltage will drop. But in case of DC machine, it is not that simple, because this EA will also vary due to some other reason. What are the reason? You know that due to the armature reaction, the EA will vary. The EA can vary due to the armature reaction. Is that clear? So if EA varies, then due to that Vt will vary. Not only that, due to that the field current will also vary. If EA, because here you see the field current also depends on this EA. Are you getting my point? So therefore, here
Yes,
the
sir.
characteristic is not straight line. If that armature reaction was not there, then it could be a straight line. But due to this armature reaction, the drooping characteristics become non-linear. Because you see there are a few interdependent things. How? Suppose due to this armature current, what happens? There is huge armature reaction, and due to this demagnetizing effect, effective flux will reduce, and in this reduction in flux, what it will do? It will reduce the armature voltage. Okay, so if the armature voltage is reduced, Vt will reduced, and due to this Vt, the field current will also reduced, and due to this field current reduction, the flux will again reduce. So that means the flux is reducing due to the increased armature reaction and due to the reduction in field current.
স্যার
বলো।
হ্যালো
হুম।
হ্যাঁ স্যার বলছি আইটা ফাইটা কেন কমছে ওটা একা বলবেন আপনি ওটা
আইএটা
এআইটা
বাড়লে
একবার
ফাইটা
বলবেন
কেন
রিপিট
কমছে?
করবেন হ্যাঁ ডাইরেক্ট না ফার্স্ট লিখ না আইএ বাড়লো ফাইটা কমলো
IA বাড়লে, if the IA is increased due to the severe armature reaction, you will get demagnetizing effect of that. That I discussed during the discussion of armature reaction. Okay, so if
Yes,
IA
yes.
is increased, its demagnetizing component also will increase. Due to that, the flux will reduce. And if the flux is reduced, voltage will reduce. If the voltage is reduced, terminal voltage will reduced. Now field current depends on the terminal voltage, because field current, this Vt by Rf is basically the field current. If field current reduced, then due to that also the flux will reduce. That means the flux is reducing here due to two reasons. One is The one is the increased armature reaction as well as reduced value of field current. Okay, so due to these two effect of flux reduction, this EA will reduce at a faster rate. And if it has a straight line like this, so it will be drooping at a very faster rate, and after some maximum value of load current, this is also called the breaking current. After certain value of the maximum value of the load current, that armature will be unstable, the armature voltage will be unstable, and it will be zero. So this portion is the unstable portion. Okay, so this is, you can say, due to this armature reaction. But for separately excited generator, you will get better characteristics. Why? Because, can you tell me why? This is for shunt.
So their IF was
IF is independent of the VT.
independent of VT.
Okay. Okay. So that means one point it will be there due to this increased armature reaction, the flux will reduce, and due to that EA may reduce, isn't it? So that point will be there, but not this point. Are you getting my point? এখানে দেখো দুটো
Yes, sir.
জিনিস আমি বলেছি, একটা হচ্ছে ফ্লাক্স ইনক্রিজ, কি বলে, আর্মেচার কারেন্ট ইনক্রিজ করার জন্য আর্মেচার রিঅ্যাকশন ইনক্রিজ করেছে, ফ্লাক্স কমে গেছে, আবার তার জন্য ঘুরে আবার কি হচ্ছে, ফ্লাক্স কমে, ফিল্ড কারেন্ট কমে যাওয়াতে ফ্লাক্স আরো কমে গেছে। এখানে এই দুটোর মধ্যে একটা কারণ এক্সিস্ট করবে ইন কেস অফ সেপারেটলি এক্সাইটেড অলসো, দ্যাট ইজ ডিউ টু দ্য ইনক্রিজড আর্মেচার রিঅ্যাকশন the flux value will reduce. Okay, but due to this reduction of this flux, EA will reduce, but EA is no way interfering the field current, because field current is independent here. Okay, so EA will no way interfering the field current, so field current will not reduce, field current will remain constant. So due to the demagnetizing effect of the armature current, the flux will reduce, that will be there. So here also you will not get any linear characteristics, here also you will get non-linear drooping characteristics, but that drop will be lesser than your shunt machine. Okay, so this is the separately excited, and I couldn't erase it. I don't know. So so there are, have you understood these 2 points, how we are getting these 2 characteristics?
Yes, sir.
Okay, so therefore the
Sir,
voltage
this-
regulation, bolo.
Sir, this Imax which you have shown, is this greater than the full load current?
It is
Because
greater
in
than the
book
full
this
load
is so
current.
mentioned that
It
this
sometimes
happens.
it is almost 200% of the full load current, sometimes it becomes 60%, 160% of the full load current, but it is more than the full load current. Full load current you can expect somewhere here, and that depends on the how much percentage will be there, so that depends on the design. So here it is the full load current or rated current. So generally the
Sir, is it possible to operate this?
operate, I'm not getting.
Sir, is it possible practically to operate a DC machine? Sir, I want to tell that is it practically possible to operate some DC machine greater than full load current, because it should be damaged then if we try to increase the current so high above the full load current?
Generally, what happens during the design, we took a lot of tolerance. So at least that coil which we use for that, at least it can carry 300% current. So the coil will not damage. So coil will not melt. Okay, but the thing is that whether you
Okay,
will
sir.
get the voltage build up or not. So that means the voltage will be there or not. So due to the heavy voltage regulation, after that it will be unstable, and the terminal voltage will drop down to 0. Still there is some current, but the voltage will be 0. The load current will be there,
স্যার
the voltage will be 0. That is called the short circuiting condition. বলো।
Okay, sir.
স্যার আপনি এখানে যে ওই আনস্টেবল পার্টটা ড্র করেছেন না,
হুম।
ওটা তো স্যার
বলো।
জিরোর কাছাকাছি যাবে, মানে ওটা তো ই রেসিডিউ বাই আর এ হবে ওটা, তাই না? আনস্টেবলের জন্য যেই
হুম।
কারেন্টটা থাকবে যেটা, ওটা তো খুবই কম থাকবে। ওটা আইএফএল এর ডান দিকে দেখেছেন,
এই ফেলে
ফুল লোড কারেন্ট তো ওখান ওর থেকে অনেক বেশি হয়। আমি বলছি আপনি যে নিচে যে আনস্টেবল পার্টটা ড্র করেছেন না,
হুম। হ্যাঁ, বুঝতে পেরেছি। ওটা তো ডিপেন্ড
ওটা
করে,
তো অনেক, ওটা তো
you are
জিরো
saying
হবে।
that it will be like this, isn't it?
হ্যাঁ হ্যাঁ,
But that
ওটা
depends
তো
on
ই
the
রেসিডিউ
design.
বাই আর এ হয় ওটা, তাই না?
হ্যাঁ, that you are correct, that uh, that will be defined by this resistance of the armature. Okay, now come to the other machine, that is series. So shunt and separately excited, I think you have understood. Series excitation. In case of series excitation, what will be the characteristics? Do you have any idea? Because in a no load condition, a series excited machine was failed to develop any voltage, but in case of loaded condition, what will happen?
স্যার মানে সিরিজের লোড ক্যারেক্টারিস্টিক্সটা কেমন হবে নাকি?
Here all the currents are same. Whatever the load current, that is equals to the armature current, that is equals to the field current, because all are connected in series. Okay, now initially there is some voltage due to the residual flux, but due to this residual flux, when the circuit is closed through the load, so some current will flow and you will get some field current also, because load current equals to the field current, and due to this field current you will get some sort of flux. So you think in that way how we can get the characteristics, external characteristics for series excited generator. It will be the inverse of,
will be fast, linear, and angle quantity.
now what kind of linear characteristics it will give? Linear means a straight line. So what kind of
হ্যাঁ,
straight
প্রথমে
line?
স্ট্রেট লাইন হবে, তারপরে স্ট্রেট দেখবে।
কেন স্ট্রেট লাইনটা কেন হবে? কোথা দিয়ে হবে স্ট্রেট লাইন?
রেসিডুয়াল ফ্লাক্স প্রডিউস করার জন্য।
Okay, so it will be the initial portion of it will be similar to the OCC characteristics. You see, because here also the voltage is getting built up just like your open circuit characteristics in DC shunt generator, isn't it? Because you see, initially there will be some flux. Due to that, you have some voltage. Due to this voltage, some load current or field current or armature current will flow, because all are same here. Okay, so due to this field current, you will get some flux. Take it delta F. delta phi, and this delta phi, due to the proper connection of field, if it is added with this, then the net flux will be increased phi 1, and that phi 1 will give you some increased voltage EA1. Is that clear? So this is how the thing will develop, the voltage will build up. So that means you will get this type of characteristics. The initial portion you will get like this. Okay, so let me erase this. I don't know why the board is getting stuck up. But after that, due to this armature reaction, again it will fall like this. Okay, so it will fall at a faster rate due to this armature reaction. Remember, in case of open circuit characteristics, there was no armature reaction issue. But here, though the initial portion of the series external characteristics is very near to this open circuit characteristics of the shunt generator, but after that, due to the high armature current, there will be huge armature reactions, and the voltage will be drooping again. Have you got this point? Why we are getting this type of characteristics?
ওসিসির জন্য কেন হবে না ওটা একটু আরেকবার বলবেন?
হ্যাঁ,
মানে আর্মেচার রিঅ্যাকশন করব না।
আর্মেচার বলো, আমি শুনতে পেলাম না।
রিঅ্যাকশন
হ্যাঁ, ডিউ টু দ্য আর্মেচার রিঅ্যাকশন
ওসিসির জন্য
নো ওসিসি মতো হবে না শুরুটা কিছুটা।
ওসিসির জন্য আমরা কেন
শুরুটা the
ওটা হবে মানে
starting phenomena will be like OCC only. But after that, due to the high armature current, there will be huge armature reaction. Due to the armature reaction, there will be huge demagnetizing effect. The net flux will reduce. একটা certain ভ্যালুতে যাওয়ার পরে ফ্লাক্সটা এবার কমতে থাকবে ডিউ টু দ্য আর্মেচার রিঅ্যাকশন। তারপর ভোল্টেজটা তখন পড়তে থাকবে। Okay.
ওকে
Okay. Now, if we have two characteristics at a time, that means series plus shunt and series let me write like this, not this, shunt minus series, shunt minus series. So this is called the cumulative compound, and this is called the differential compound. So what type of characteristics we'll get? For series plus shunt, that means there you will get addition of these two characteristics, and depends on the in how much proportion they are getting added. So therefore we'll get this type of characteristics for cumulative compound, because here two characteristics are getting added. So therefore initially there will be some increase due to the increasing portion of the series characteristics, but after that again it will drop. And for differential characteristics it will get more drooping, because the series field is negating that shunt one. So this is the differential one. Are you getting this? In case of differential compound, the series flux contribution will oppose the shunt field contribution. So therefore you will get stiff drooping characteristics for differential compound differential compound external characteristics. But for cumulative compound external characteristics, you will get initially some increase in voltage, then you will get the drop. Okay, now the cumulative compound can vary by varying this contribution. Suppose I am varying the series contribution. Okay, so depending on the series contribution, then we can change the characteristics. How? Let me draw here. I'm not getting why the board is getting stuck. Okay, so suppose this is the load current and this is the terminal voltage. So this is your EA, and suppose this is your full load current. Okay, now by adjusting the series field, you may have the characteristics like this. You may have the characteristics like this, or you may have characteristics like this. Okay, so that means at the full load value, so this is the full load voltage. So this is the full load voltage. At the full load voltage, your voltage can be equal to the no load voltage. These are all cumulative compound. Remember, these are all cumulative compound. I am only varying the series field contribution. So at the full load current, the full load voltage can be equal to the your no load voltage. Okay, so the EA is the no load voltage, or you can write also EA0. The full load voltage can be less than also, just like the lower one, and the full load voltage can be more than EA0. So this is called the level compound. This is called the under compound, and this is called the over compound. Any question? Joyot, do you have any question?
No, sir, sir.
Hmm? You have raised your hand, so
No, sir,
therefore I am
ঠিক আছে।
asking. So, okay.
তো ভুল করে হয়ে গেছে।
Okay, no issue. So I think you have understood these points, how we are getting this different characteristics, external characteristics for different types of excitation. So all these for cumulative compound machine, but if we change, if we vary the series contribution, we can get a different characteristics. Some characteristics will give you level compound, some characteristics will give you under compound. Remember, for level compound, initially you will get an increase in the armature voltage. So that means there the terminal voltage can be more than the no load voltage at some point. At some point, the terminal voltage can be more than the no load voltage. Okay. So that means in that case, the voltage regulation will be negative. Now, I think you don't know what is the definition of voltage regulation. Okay, so the voltage regulation. Voltage regulation. Do you know what is voltage regulation?
Yes, sir.
From where you know this? From transformer?
Sir,
Transformer.
transformer.
So what is voltage regulation?
So no load voltage minus full load voltage by rated voltage.
No load voltage by full load voltage. Okay, by rated voltage also full load voltage you can write, because full load voltage is generally to the rated
Sir,
voltage.
এটা না
And some books
Sir,
also by EA0
এটা
is also
কিছু কিছু
mentioned.
জায়গায় আবার নো লোড ভোল্টেজে থাকে।
হ্যাঁ, অনেক জায়গায় আবার EA0 থাকে। So anything you can take. But the numerator, the voltage drop is
Denominator-এ
more important.
EA0
and-
থাকবে না?
বলো?
ডিনোমিনেটরে EA0 থাকবে না?
E0 থাকতে পারে বা ফুল লোড ভোল্টেজও থাকতে পারে, depending on for what is the reference. If the reference is your rated voltage, then you can divide by rated voltage, and if your voltage the reference is your no load voltage, you can divide by the no load. মানে this is the per unit system, na? What is your base? What is your reference? Okay. Accordingly, your definition will vary, but the numerator is the most important thing. যেটা হবে, the percentage will vary slightly. Okay. Now here for these generators, different generators. In some generators will get the negative voltage regulation. Okay. So for what type of generator we can expect negative voltage regulation? For cumulative compound only. For cumulative compound generator only we can get some negative VR. But for other types of generator only we'll get some positive voltage regulation, and we'll get the maximum positive voltage regulation for differential compound machine. Differential compound machine, we can get the maximum voltage regulation. Okay. And sometimes there is a question that why we get more voltage regulation for shunt generator compared to the separately excited generator. The answer already I have given. Okay, so why we get more voltage regulation in shunt generator, DC generator, compared to the separately excited DC generator.
So voltage drop is higher for shunt generator.
Voltage drop, correct. So that is the thing. As I told you during the voltage regulation discussion in transformer, that the voltage regulation is nothing but this term, the voltage drop. How much is voltage is getting dropped at full load condition or any loaded condition compared to its no load value. Okay, so as I have mentioned that in separately excited generator, the voltage drop is less because one reason of voltage drop is not there, which was there in shunt machine. That is the independent field current. In separately excited generator, the field current is
DC.
independent of the armature induced voltage. So that is the reason for which the voltage regulation is better in DC separately
Separately
excited generator. Okay, so any question you have? Okay. So sometimes the level compound also called the flat compound. Again, that depends on the design of the machine, because once the machine is designed, then you cannot change the type of excitation. If that is giving you a level compound or over compound or under compound, that will be fixed. The characteristics will be fixed. Okay. Now, what is the next I discuss? Next, we will go for this DC motors, because DC generator. I just let me see the syllabus. Whether we have something else to be discussed in DC generators. Okay. So the short circuit current, I think that he has rightly pointed out. I may be mistaken the curve. As he has rightly pointed out, this point should be, as I told you, this point is basically the short circuit point, and the short circuit point will be the value corresponding to the, the voltage that is called, because is a rated voltage by the armature resistance. This value will get there, not this value. Okay. Do you have any point? I think this is quite easy to understand compared to the things we learn in this commutation or armature reaction, etc. Isn't it? But you can experience lots of numerical problems. So let me start some numerical problem if we can discuss here. So which book you are following for numerical problems? Because I haven't discussed any numerical problem in this class. But you have to work out a lot of numerical problem to understand the thing more in more details. So which book you are following for numerical problems? Is it Bhimra only?
Sir,
Or
PS Bimra.
okay, so PS Bhimra is a good book. A
So
lot
that
of
is
problem is worked out there,
most common.
and some number of problems are there in exercise also. Okay, so that you can follow, but side by side you should go for some other book, like uh, as I told you that there is a very good book for numerical problems, that is a Parker Smith. So Shastik has already pointed out that. Okay, so Parker Smith, N. Parker Smith, uh, Problems in Electrical Engineering by N. Parker Smith. That book you can follow. A lot of problem is there. Okay.
স্যার ওটা কি শুধু ইলেকট্রিক্যাল মেশিনের প্রবলেম নাকি মানে
no.
সব ধরনের প্রবলেমই আছে?
Mainly core engineering. The book generally follows the core
আচ্ছা।
engineering because that is a very old book. There most of the recent engineering like this power electronics and control system, all these recent topics in electrical engineering are excluded from that book. So only you have the core engineering like power system, electrical machine, some instrumentation, not the advanced instrumentations, but the old instrumentation, like the thing you were studying in instrumentation, like analog instruments, in indicating instruments. Those are covered in that book. But that is a very good book. You can consult that book, and till today in most of the competitive exams, uh, the questions are taken from that book. Most of the competitive exams starting from GATE, IE, engineering service, etc. So that I can ensure. If you can solve at least 50 to 60% problem you can solve yourself, then you will get some confidence that you are learning electrical engineering. Okay, but don't go by the solution book. Solutions are also available in market in 2 volumes by VT Natesha, but you don't go by that book. Only you can buy this book by Parker Smith and you can solve the problems from that. Okay, so let me conclude for today, because next day I will start the electrical. I will start the DC motor part, including the DC generator. The next day I will start the DC motor, and let me think about anything I have missed from this DC generator. If I miss something in DC generator, then I will discuss those. Okay. So if you don't have any questions, so let me take the.
স্যার আমার একটা কোশ্চেন আছে, মানে আজকে পড়ানো থেকে না, আগের দিন আপনি বলেছিলেন যে কমিউটেটরে কি ধরনের প্রবলেম হয়েছে, মানে কমিউটেশন প্রসেসে, সেটা স্পার্কের কালার দেখে আমরা বুঝতে পারি, যেমন হোয়াইট ইজ আন্ডার কমিউটেশন বা এরকম। তো মানে কালারটা অ্যাকচুয়ালি জেনারেট হয় কি করে, মানে ডিফারেন্ট টাইপ অফ প্রবলেম কি ডিফারেন্ট টাইপ অফ মানে কেমিক্যাল রিঅ্যাকশন
No,
তৈরি
not
করে,
chemical
যেটা থেকে
reaction.
ডিফারেন্ট টাইপ অফ কালার
Not
আসে?
chemical reaction. That you can say that depending on the temperature. Okay, those spark color depends. Depending on the temperature.
আচ্ছা, মানে ওই টেম্পারেচারটা,
হ্যাঁ,
আচ্ছা মানে টেম্পারেচারটা ডিফারেন্ট হয় ডিফারেন্ট টাইপের প্রবলেমের জন্য।
different types of problem এর জন্য temperature different হয়, আর formation টা different হয়। So that you can get the answer from illumination engineering, because they deals with this type of thing, which temperature and which temperature corresponding to which type of radiation, because that all depends on the band. Okay, so which band it is emitting. Anyway, I don't know in details of that, because every temperature has some correlation with this band of color radiation. So anyway,